Alright, now you guys remember that position and velocity have a calculus relationship, right? Yeah. Do you remember which one was the derivative of which? Position, velocity, and acceleration. We often stack them up. Position, velocity, and acceleration, because that's the order that they are as far as them being derivatives of each other. So position could be considered x of t, whereas the velocity would be x prime of t. Acceleration would be x double prime of t. That was what we looked at in the past. What we're going to do now is we're going to reverse the process. Instead of differentiating, we're going to show that velocity is an antiderivative of acceleration, and position is an antiderivative of velocity. The question says, assume that a velocity of an object is given by -3 meters per second. So if we draw a graph, this is an easy one to start with because the velocity is just constant. It's a nice horizontal line. But they're asking us to construct the position graph for this object given that that is his derivative. So they make you wonder, like, what function has a derivative of -3? They also give you information about the starting position, that it starts off at 4 meters, which could be like up here for the x. What function do you think we're trying to make, given that the position function is an antiderivative of that -3? I'm saying that x of t is an antiderivative of -3 dt. So what is just the antiderivative of that? We have to change it into his antiderivative by adding a variable. So -3t. What else should I put? I can't just put -3t. Yeah. Plus c. Now what's the c in this particular situation, do you think? See, the c has a meaning, a physical meaning in this case. It could be called, say, xi or something. The initial position of the object. And we know that according to the givens, xi is 4. Therefore, the formula that they're looking for here is x of t is -3t plus 4. So when I go to the program, that is what I want to graph. Sometimes it's a little tough for people to graph these. Webassign's kind of picky. It says here they want the line icon. So choose this. Draw your velocity as a nice horizontal line. Then in the graph above, you want to graph this guy. Now they give a piecewise-defined situation. Okay, that's a little tougher. They say, what if the velocity was -2 for all times to the left of 2 seconds, and then it changes to a 1? We can graph that. So let's say we have velocity. There's a sudden change that occurs here at t equals 2. They're saying the velocity is -2 for when t is less than or equal to 2, and it becomes 1 for when t is greater than 2. Okay, let's graph the original velocity function. It's going to have a solid dot here. And then it's going to have an open dot up here at 1. It's going to look like that. We want to plot the position function that goes along with this graph now. Now, do they give us any more information? They say, assume that, at t equals 0, the object is located at the origin. You always have to have that, some kind of initial condition given in order to plot your function, your antiderivative. Now, we want it to have a negative slope for this region, and it can have a positive slope beyond that. So what we can do is write our position function, where each of these is an antiderivative of the formula below. So for times that are less than or equal to 2, what should I make my formula? Negative 2t plus some unknown c. But if we really look at the situation, we can infer what the c here has to be. The c is 0 because this thing hits the axis, the y-axis, at the origin. So that c is a 0. We can then sketch our line, and then after that we have a new formula. What do you think the new formula is going to be for when t is greater than 2? Okay, 1t I agree with totally, because this is a 1. He is the slope of him, so that is good. But then, right, there has to be some constant here, and we have to think about what that constant really is. We need, for this formula, to predict where our object is located. And so we have to use a point where we know the line goes through. So what is that point going to be there in coordinate form? 2, 2, -4. It goes through 2, -4. But we can't make the c the -4, because that would mean that the thing had started here, and it wouldn't totally give us the right prediction, because we need it to land up so that it predicts these positions that look something like this. So if we extrapolate that back toward the y-axis, we could kind of get a sense of where about the number is, where it touches, right here. We could calculate what it is. All we have to do is just on the side say that x equals 1t plus an unknown constant, which we don't know what it is. Plug in the t of 2 and the x of -4. And now we can solve for what that constant truly is. It must be -6. So now we can put in what that constant is. Piecewise antiderivative. That's pretty cool. When it does ask you to graph these, you have to just pay close attention to the instructions. It says make a ray for t less than or equal to -2. So in the velocity here, so we'll go like this, and then you have to make a new ray though for the other one. Choose the ray icon with one endpoint and one arrow. Should be able to do that. Now you can edit the rays to make them either open or closed dot. So I want my ray 1 to be closed dot, but I want my ray 2 to be open dot according to the function they described. So let's submit that. Yeah, for our position, let's try to construct what we did. Here, I believe you have to use all closed dots. It says don't use any open dots. So like that. That would be good.